Grow here. Uh, this is part 3 of my video series uh, explaining the space-time superposition chart that I developed. In the last video, I focused on the universe of the 147, what I refer to as the 147 universe, which is consisting of the first dimension, the fourth dimension, and the seventh dimension. And by consisting, please understand that all of these dimensions are operating together. The first one all the way to the ninth one. But because of time and our interactions with time, we are calibrated to the first, fourth, and seventh dimension in this part of the universe. I'll put it that way. This is the part of the universe that we are operating in. I'm zooming right here. The first, fourth, and the seventh. And like I said in my last video, you have a planet. We see the influence of the dimensions just by looking in outer space. We see a planet, we see an axis, and we also see a gravitational pull. So we see these effects here, and we see some residual effects of some of these other dimensions. But primarily, we see that we are here because we see the great influences of the dimensions on our part of the universe. But what about these two? What about the 2, 5, and the 8, and the 3, 6, and the 9? What about this part of the universe, these two parts of the universe? I wanted to focus on the 3, 6, 9 because it's the polar opposite of the 1, 4, 7, according to the chart. Now, I wrote on my blog that it's very difficult to think that anything could exist here because we have three-dimensional space. We have only one dimension of time, which is the sixth dimension. And then we have a dimension of space-time, which seems to push everything apart. You see, if you go here, gravity is caused by the seventh dimension, which is the compression of space-time. Scientists say and physicists say that the space between the atoms are so great that, you could have a small piece of matter and the space between the atoms in that matter would probably be about, the size of in comparison, the size of our entire solar system. So if you look, and that's the seventh dimension, we see that when you compress that empty space, you can actually squeeze matter. You can squeeze matter probably to the size of a very small object. It would weigh a whole lot, but all the empty space in between the atoms will be removed. And I saw a video where it said that you could take the Empire State Building, remove all the space between the atoms, and it would shrink the entire building down to the size of a grain of rice or something like that. So here we see a black hole doing space-time compression, basically compressing the empty space between the atoms. Now, the opposite of that, or the opposing position, would be space-time decompression, which the ninth dimension is doing that. This drawing that I made of the ninth dimension is somewhat incorrect. I did it just to show how it's operating. It's more flat. The seventh is more shaped like a funnel. The ninth is more flat. It doesn't extend out like this. It extends more from the center going out. Kind of like here in the eighth dimension. See that little ring with the rings coming out? It operates more like that. But I just showed it, to help you understand that you would be coming out there at a 90-degree angle, when you come out. But the ninth dimension, we would have space-time decompression. So if gravity is caused by the seventh dimension, which I put some quotes from Wikipedia on there concerning Einstein's theories on relativity, and if the seventh dimension was causing gravity, then we would have to assume that the ninth dimension, which would be the opposing position, is causing levity, which is the opposite of gravity. I don't know if that's an official term or whatever, but that's the only word I can find in a dictionary that describes the opposite of gravity. So I'm using the term levity to describe a polar position from gravity, or an opposing position from gravity. So here we have a levitational force, or not necessarily force, but we have the effects of levity here, where all matter is being pushed apart, and we have one dimension of time, and we have three-dimensional space. How could anything form here? All matter will be pushed apart. So anything that, would try to come together, it would simply just scatter. And we have one dimension of time. So the sixth dimension has an effect when you put it together with the fifth, and it forms the fourth. Both of these are operating in two parts of the temporal sphere. And I'll go into that in another video. We have one dimension of time, three-dimensional space. So I want to show you something. Here we have gravity pushing inward to a point, and here we have levity pushing outward. Now, if you look at the 147 universe, I said we had a planet here, which is a superposition. So we have everything in this universe is spherical because we see the effects of time, the fourth dimension. But here we have one dimension of time. So how can anything be spherical? How could anything, what shape would objects take here? Well, if you look at this, we have a superposition here, which is consisting of the, I don't know if you can see this, of the fifth dimension and the second. So we have, subparts of this superposition that are actually sitting here. Remember, superposition consists of the first, the first two positions and then a neutral position. Well, here we see the same thing. We see the first two positions and then we see a neutral position. But look, we have a 5 here and we have a 6 here. So when you put these together, guess what forms? You get a sphere, because the 5, the 6, and the 5 from the 9, the 5 that's part of the 9 will combine to form a sphere. So now you have a fourth dimensional sphere when you put these two together. But you still have the effects of levity, which is still pushing things apart. But there is a sphere here. And if you look at the center of the sphere, you would have three-dimensional space. So here you would have a planet with an axis and a gravitational pull, which explains why the Earth is solid at the center, and then you have magma, mantle, and a crust. Here, everything will push apart. So how can any planet form? How can anything form at all? Well, you have to think about it. In our universe, NASA sends off a rocket into space using huge amounts of energy to push it out, whatever the term is, where it escapes. I don't know, they call it escape velocity, where it has to have enough force to escape the gravitational pull of the Earth. But as it moves away from the Earth, the effects of gravity become weaker. So it doesn't need as much force. And then everyone sees that the satellites and stuff use these little steam jets to move around, and and they can stay up there in orbit. They don't have to use huge amounts of fuel to stay in orbit, because they're far enough away to where the effects of gravity are not as strong. So the further you move away from the Earth, the weaker the effects of gravity are. Well, then we would have to assume that the same thing applies here. At the very center of the sphere, you would have the strongest force of levity. But as you moved away, that force would become weaker and weaker and weaker. Now, remember I told you earlier that even though we are here in the 147 universe, we are all still part of all of this. Remember, we have three-dimensional space which is formed. So we're timing, our timer of the matter in our body is set in alignment here. But the effects of these are also seen in our universe. So we would have to assume the same thing for this universe. That as the force of levity pushes you away, it gets weaker and weaker, you have to take into account the residual effects of the 147 on the 369 universe, which means that as matter got pushed further and further away, it would reach a point where the effects would become so weak that the effects of gravity would show up, or the effects of the residual effects of gravity would start to affect the matter. And then what you would have is an equilibrium zone. Let me take this form here. Let me take this sheet here. And you would get something like this. This is the 369 universe. You have levity coming out the center, but then you have the residual effects of gravity pulling in. So you have gravity pulling in, levity pushing out, and here you would have an equilibrium zone where matter would settle in. It would be a planet. A planet could form, but the planet would be hollow on the inside. It would be a hollow Earth. In the Earth, the effects of levity, you could actually live on the inside of the sphere and build cities. And because of you could build cities on the inside of the sphere and on the out. You have the gravity, which would be pulling down into the sphere. You could build a city and stay on the outside of the sphere. Or you could be on the inside and levity would hold you to the crust. So you would have a hollow Earth. And anyone, and I'm not going to go into this, but you could Google hollow Earth theory on the internet, and you're going to come up with a lot of interesting stuff. I'm not going to go into that. So this would be a hollow planet. The 369 would be a hollow planet. You would have floating boulders. You could have water, oxygen on both sides. You'd have water that could possibly, entire oceans that could fill up this equilibrium, and then land masses that actually float, you know, like continental drift, but it would float in this equilibrium zone. It would look kind of like the movie Avatar, where you'd have floating boulders and things like that. But you, for the most part, you could have large land masses, water, air, oxygen, and you could have an entire civilization on both sides, and even maybe, you know, some tunnels or whatever connecting both sides, maybe through water or whatever. You could, you know, there's all types of things that could be here. But the planet would be very, very large. It would be extremely large. Now, if you look, I don't have it on a graph here, but we see the residual effects of these other dimensions just by looking at our solar system. The Earth doesn't have rings around it, but Saturn does. We can see some of the effects of some of these other places by looking at our own solar system. For example, one planet that shows the residual effects of the 369 universe is Jupiter in its large size. I believe it's a gas giant. That's what they call it. Well, that's the residual effects of the 369 universe are showing up in Jupiter. The residual effects of the 258 universe are showing up in Saturn with its rings. I'm not going to go into it a whole lot right now, but the 258 is would be a flat planet. It would be a flat Earth, which you could Google flat Earth on the on the internet. You'll come up with a lot of interesting stuff from the past also. So I believe, and it's my honest belief, that we did not originate here in this part of the universe, but we migrated here from these parts through these space-time bridges, which in another video I will go into, that link these parts. There are these space-time bridges that link these, and I think we migrated from these places to this part of the planet. And that's all I'm going to say for now. Stay tuned for my next video. Thank you.